house, but we were listening to EW signals via the boat. We recorded depth soundings. I'll show you a thing that in a minute. Obviously we can do weather, we can track animals if we had the right thing. We can give, with 8 hours of sun, we can get it with 300 watts coming in, and that gives you 2.4 kilowatt hours. Divide by 24, that gives you 100 watts an hour. 10% losses, that's 90 watts an hour. We use 40. So we can give 50 watts an hour, 24/7, to a payload. And we've experienced Moore's Law. You all know what Moore's Law is? So we have lived in the ferry business through this. We've lived and experienced that in real time, where something weighed 400 kilos as a sensor and used 400 watts and cost $400,000, and now it's a computer chip. And what I'm talking about is a GPS that can measure the height, the Z-axis. So if we had a bunch of blue bottles out there off Darwin, which Darwin, by the way, gets 11 hours sun, so it makes the maths a lot easier. If we can measure the height, we had enough of these out there, then if there was an earthquake in Indonesia, we could measure the height and direction of the tsunami. What else can we do? Well, by default, we've got a weather station. We're looking for pressure. We're measuring air pressure, so hurricanes follow low pressure. So again, if you had a fleet of these off Darwin, you could tell where a hurricane was going to make landfall. This is something we have very, just back a bit, we have very basic optical target recognition software. Pretty much it gives, doesn't really say what it is, but it says it's not the horizon water, it's something else, shouldn't be there. And so that alerts a human to download the picture. And fishermen, for whatever reason, don't put their AIS on, even though they're legal fishermen. They don't put it on because they don't want to let their other competitors know where they're fishing. So we got this photo. We were just there watching the computer, and up it came as an alarm. And so I went down the harbour and showed this to the local fishermen and said, "Do you have your AIS on?" And they said, "No." And I said, "Oh, could you see us?" And they said, "Yeah, we can see you on you because we have our AIS on." And at the end of the day, what everyone thought would be a very difficult conversation came down to the fact that they said, "Can you send us a picture of our boat?" That's what they wanted. Next slide. As I mentioned, we built this one to carry a 105 kilo winch, but if you click on this one, we have also had inquiries about like a movable buoy or buoy type one, and this is my friend Bruce, the surfboard guy, putting some 10 kilos of house bricks into a 5 kilo vessel that you could basically chuck off the back of any boat, and he chucks it off the beach. So again, this is Northern Territory perhaps applications, and you'll see in a minute how the flipper works. So fundamentally this thing is just using wave power. It's just one moving part, which is the rudder, and you just point the rudder to wherever you want to go. So that's a very, very basic prototype. It's got no electronics in it. It's just empty, but it's just another concept that we've been investigating. So this is the second. This is our second one. So we've got Bruce, and now we've got Bob, and this is Bob. If anybody knows, that's Pigeon House Mountain, which Captain Cook named as he came up the east coast of Australia. And one of the things that we can do is use landmarks like that as geolocation in the event of loss of GPS. Next one. So this is Bob going out, and this is using solar power. So it's using about 300 watts. So you could do this while the sun's shining. You could do this forever. We're going into about an 8 to 10 knot breeze and just heading out using the flipper. So we can actually set the boat to say we want you to maintain a minimum speed of 1 knot, 2 knots, 3 knots, and it will use whatever energy it can, and then add it with the propeller. And I'll just keep. So again, on the comms mast, for Autonomous Warrior, we had mesh radios, so we were actually another radio node. So the ground station could talk to us, and we could extend, like a cell network, we could add to it. In the front compartment, we've got all the mechanical, mechatronic stuff, so for the rudder and the sail. The middle compartment over the keel is entirely for the customer payload, so it's 150 kilos of dry payload, 150 kilos of wet payload, and the back of the vessel we've got we've got 50 kilos of batteries and the communications and the computers that run the boat, and we've got backup computers. And here we are sailing. So this is using no propeller. This is again 8 to 10 knots breeze, and we're probably going 2.5, 3 knots. And again, we can do this sustainably. And this is, I'm very excited about this. This is 4:13 yesterday morning. We just finished 9 days of sea trials. AMSA, which is the Australian Maritime Safety Authority, equivalent of CASA. We've been talking to them for 2 years, and they gave us a box. And they call it a box because it's three-dimensional, so it's for unmanned aerial vehicles and UUVs as well as surface vessels. A box for the testing of unmanned systems, autonomous systems. And we spent 9 days in the box. There is a thing called the East Australian Current coming down here at 1 to 2 knots. So initially we biased Bob up towards the top of the box. We did a bit of exploring down the bottom. You can see some sags in various lines where the current is sort of running northeast to southwest. We brought the boat in on about day 5 and Wi-Fi'd a whole bunch of updates of the software to compensate for the fact that if you're sailing at 2 knots in a 2 knot current going sideways, that's like an unmanned aerial vehicle flying at 100 miles an hour and 100 mile an equal amount of wind. So it kind of changes all your PIDs. You want to know what PIDs are? You can explain what it is, I don't know. It's something to do with, it's basically how you're steering the vessel, right? So we came in, updated all the things, the boat then just sailed brilliantly, and we went down here, and here we go. The wind had turned to the south, so south wind, and they name winds after where they come from, currents where they're going. But so we had a southerly wind and a southerly current. So the wind's going that way, and they're going in opposite directions. So we actually just tacked down here, and roped Bob, and then we started getting home. So that's my modern art signed by Bob. Next, and you can see we're measuring wind. And that's water temperature, by the way. So again, we were measuring 3 things. We were measuring water temperature, depth, and current. And the water temperature came out the prettiest, so that's what I picked up. So we've been presenting to Defence about, what could this do? And this is an example of 300 blue bottles deployed from Darwin. Each of them has a area of a radius of sort of listening and under the water listening and above water listening of 15 kilometres. So that makes each of them like a 30-kilometre radius. That's Ashmore Reef, that's Christmas Island, and just press it. So this is all, okay. So they could have sensors under the water and above the water. Big thing about ships with men in them is that if you've got a 70-day duration, it takes you 15 days to get out there and 15 days to get back. It means you've got to spend 40 days on station. If you don't have transit back, then you think you'd be out there for a long distances from the thing. And if you had this number of drones, one a day could come in and get the bottom cleaned and barnacles and put out again. As I mentioned, you don't need any new infrastructure. We obviously need people. It's disruptively low cost because there's no fuel, there's no men on board, there's no overtime. We don't use oil, so we're free. We don't have that sovereign. We don't. You may or may not know Australia runs out of oil 20 days. Couldn't get oil from the north, and it's just all Australian technology. And there's nobody in harm's way or getting bored or homesick. So what could you use it for? Obviously defence, home affairs, fisheries, oil and gas, science. We can, under this Moore's law, we can just carry more and more sensors and oceanographic research. This is Bob doing wave power. Just press the button there. Sorry, next one. Yeah. So this is a simulation of if you had a bunch of them. And this runs a bit slow, but bottom line is here the blue bottles are going at 2 knots, the commercial vessels are going at 12 knots. These are P8s or Tritons sitting here. and at some point a fishing boat leaves. Sure, okay? Yeah. We get the fishing boat leaves, picked up by these guys, so we're a virtual barrier, and we cue a Triton to come and take off. There's a Triton going across there. And then of course the boat goes back, whatever. And then we get some intelligence that a submarine's coming down here, and for submarines under the water and it's a diesel electric, it's not going that fast. If it's above the water, it's going faster, it's making a noise. But the point is that if you have enough of these things, quantity is a quality. You don't have to be going fast. You can be basically persistently out there, and by the time this sub gets down to here, the ring of ones around Christmas Island have moved over and formed another ring. The ones down here have formed another virtual barrier. So our contract at the moment with the government is in the next 2 months we'll be finishing that up. In September we are proposing that we would get another contract to build 5 more blue bottles and deploy them as a squad here at Darwin to go and guard Ashmore Reef, and then go and guard something else, and then go and guard something else. So yeah, by the time the sub's coming through here, so it's picked up by this line. I think it changes colour. Yep. And then the Tritons take off. So this is just not classified stuff, but it's just an example of what these could do. And of course, while they're out there, they can be doing the hurricane prediction, the tsunami warning, the weather, the climate, the oceanographics, temperature, pH, all that stuff. So this is my second last slide. Basically, this is our payload bay. We've got this enormous payload bay here. It can have a cassette in it, it can have a winch in it, but it could put the cassette, have anything else in it. What do people want to do? Next slide. So that's it. Just back here. Thank you. So everyone, you have blue bottles up here?
Thanks for that. Excellent. Yeah, so great opportunities there for centre, I think, great synergies. It's great. I think I always thought, when I thought about remote path systems, I was thinking about aerial stuff, and then when Robert contacted us, it was just like, wow, what a great angle, you know, we're just doing it all very different logistics, but a lot of common problems as well. We've got problems with Castle, they've got problems with us.
Yeah, just a quick question.
Thank you, Hamish. Thanks to Hamish and Marianne for inviting me along. Us at the supervising scientists are super excited about this centre if it gets up, because we feel like a really good gap in the market for the stuff that we're involved in. So I'm an applied scientist with the Department of Environment and Energy, and I feel very fortunate to be in the position I'm in. So what I do is I take calculated risks based on our theoretical knowledge of our understanding of remote sensing and sensors, and we apply those to drones to get better measures for our environment. And what we deal with is really rapid R&D cycles, and everything that we do actually gets put into policy in a really rapid turnaround time. So it's a bit of a wild ride for myself and my team, but it's definitely exciting and a really great thing to be doing for environmental protection. So for those of you who don't know who the Supervising Scientist branch is, we've been located in Darwin, and formerly most of us were in Jabiru many years ago, for the past 40 years. And we were established to protect the environment of the Alligator Rivers region, of which Kakadu is part of, from the effects of uranium mining in the region. So our major remit at the moment is around protecting the environment through the rehabilitation and closure of range uranium mines. So a really big task. My team in particular, we've been deriving ecosystem restoration standards in really rapid timeframes, using drones to measure the environment. So we've had a drone program since late 2013, and we started off back in those days. Those of you who've been in the game for a little while will know that we're relying on sort of military type big swings, and there wasn't a lot of reliable stuff out in the marketplace, so we started with bungee launch fixed wings with motors that are close to your face. Not the safest operation, but these were our workhorse for many years, and the tech came out of New Zealand Defence, and it was really great for operation up here. What we managed to do was piggyback off the R&D of another university in Australia. So they paid for the R&D to get this developed to fly mine sites, to look at rehabilitation of mine sites. So you could crash that into, like it would do a parachute to land, and it could hit rocks, and it was ready to go again. So, Kevlar nose, that sort of thing. And then we started our first foray into the heavy lifts. Wasn't the best either back then. We went with the Griffin Dynamics, and it was one of the scariest things I've ever flown, and we got rid of it pretty much when, it's interesting, there's some laterite out at the East Point Model Aircraft Club, and it must have interfered with the onboard nav, and it just tore off across the airfield, and I managed to get it down, and that's when I realised this thing could kill people. It's gone. So, as much as the whole DJI experience, I tried to keep away from that. Being a scientist, we like open source stuff and all that sort of thing. We ended up having DJIs and 600s, and we haven't looked back since then. So yeah, basically we have a really strong science capability too at the supervising scientists. So more recently we've been, I think the department's discovered our science capability. So we've been doing work in other places around Australia. Recently we did some work down at Perth with the Emission Reduction Fund, for those of you who know about the sort of government's role in sort of looking at carbon and emissions reductions, and we've done work in Alice Springs and a few other places as well. So we're starting to ramp up to do wider environmental monitoring work for the department. So as I said, some of the projects that we're working on, we've got, we're mainly looking at deriving metrics for species composition. So, typically when you develop assessments for how ecosystem health or looking at disturbed land remediation, things are done at like quite small scales, 50 by 50 metre plots at the most, and people go out and they survey them. Yes, you can get information from satellites, but when you're looking at these sort of metrics, you need stuff at the tree level, and we can't really get that sort of level of detail with satellites. We can get some grosser metrics, which are great, but we also have the challenge of some of our atmospheric conditions and wet season and fire up here. So drones are great because we can get them below the cloud level, we can take them out in the wet season. We're starting to answer questions about science and ask questions about the savanna ecosystems and the wetlands that we haven't been able to ask before or even think of, because we're seeing them coming through the data in our drones. So yeah, we've got things like stems per hectare and percent cover for actual species that we're starting to pull out of our data. We're looking at deriving structural metrics. So these are like your age class of your trees, your DBH, your diameter at breast height. So for the forestry sector, they're quite used to using those sort of measures. And we use LiDAR for that. And the main thing that we're working on now is scaling these results from just that small 1 hectare plot up to at least 1,000 hectares. So that requires a leap in the technology for us. So we're doing a foray into VTOL drone. We're getting one sort of put together next year, this financial year coming, and we're going to use a Foxtech baby shark. And for some reason, a lot of the drone gear we're using is named after sharks. I don't know if that's an aviation thing, but our hyperspectral sensor is a micro shark, and the VTOL platform's a baby shark. So what we're going to be doing is our first and easiest sensor to integrate and scale is the LiDAR by far, and I'll show you what's our hyperspectral data collects and some of the challenges with that. These are just, I'm just going to whiz through some examples of some of the work that we have done in the past. So looking at how disturbed lands, you can monitor them over time at the tree level. So this is Jabiluka mine site. It was never really mined, but they put it into care and maintenance and started a revegetation program there in late 2013. So we started flying there, but we started changing our sensors and our platforms midway through this. We developed an analysis technique that enables us to doesn't matter what our data source is, we just apply that technique and we can extract the information we require on the revegetation. So this is where we're uniquely positioned, where we have people who can muck around with the tech, but we've also got the data analysis capabilities as well. And this is the sort of thing we do. We have a toolbox where we can just run through what the fate of that actual revegetation is doing over time. And this is only just one time slice from beginning to end, but we can look at the effects season has as well on that revegetation. Some other work that we've been doing, and we're starting to refine this now, we've got some high resolution cameras, is looking at flowers in the understory of the grass to actually identify understory species. So this is just using a phantom. So what we try and do is use technology that is cheap and effective and can be uptaken by industry. Because it's no good if we're science boffins just making custom built stuff and no one can use it. We need to have our stuff applied by industry or taken up by industry. So the phantom's cheap as, so we fly above the canopy and see what we can see above the canopy. So something like the gomphrena, it starts to, we know that we probably can't sense that from above canopy. It drops out about 10 metres. Whereas spermacoci, yeah, we can. So what does this mean? We really need some sub-canopy drones. So we're not game yet. I'm trying to push the guys to take the M200 and try and run some transects through the savannah and hope that all the collision avoidance on it will just keep it going back, like, you know, go around a tree and keep on its transect. So if anybody's working in that sub-canopy, like, or collision avoidance space, please come and talk to us, because I'd rather not start trashing our drones, but we'll muck around with them if we have to. This is the data that we've been pulling out of our Corning microshark. So another point is most of our sensors do come from the US or Europe. There's not really a lot of sensor development in Australia, which is a shame because they're often not tested in the environmental conditions that we have in the Northern Territory in Darwin. So we have high humidity and high temperatures. So we'll say to a provider, where have you tested it? Oh, it works up to 50 degrees Celsius. Yeah, have you tested it in like 42 degrees and 85% humidity? No. So there's a real opportunity for the territory here to provide a test bed for companies to really test their stuff in a higher end range in terms of humidity combined with temperature, because it affects platform, how platforms take off, particularly fixed wings, and it affects the sensor operations. There's times of the year, say October, November, say we've been down the South Alligator Valley in Kakadu, when our sensors will just sometimes fail. They just cannot cope with the conditions. So this Corning microshark has 150 bands of data. You look about, that costs about 50 grand for a sensor like that, and it's about that big. You can put it on M600, and that tells us a whole pile of information about vegetation, health, and hopefully we're using it to identify species. We did look at getting a shortwave infrared recently, and that really works well for looking at moisture content in things. And we started getting quotes on it. So the Corning version was $513,000 US, and we almost died when we saw that. And the cheapest price was actually probably one of the better ones we could have got too, was 225,000 Australian dollars out of a Norwegian company. So that shows you the sort of price range of some of these sensors. So for us to go ahead with that, we want to be damn sure we're going to get some good information out of it, and I probably wouldn't fly that over a wetland. This is the Belladyne Lidar that we used to have. We've upgraded since. So this is an example where we partnered with an Australian company to build us a system that wasn't available on the market at the time, but also a system that was at the right price point for industry and would work up here for sure. So this is a company in Newcastle Airsite. We did an R&D spend with them, and they built this system called NextCore. So it's now upgraded from a Belladyne Puck to a Conergy M8. Belladynes are interesting. Why we actually ended up moving, even though the Conergy's turned out to be a better sensor, is with the driverless car market, Belladynes were in high demand. So they started becoming increasingly difficult to get hold of. So this is where you have competing parts of like, say, a large market segment can actually impact each other. So what we've got here is this is the Litchfield super site. It's part of a nationwide environmental monitoring program, and lots of data, lots of equipment out there. So it's a fantastic site for a centre like this to use as a test ground. And we can actually measure the height of the trees better with this system than putting our people out in the field with rangefinder. So there are a whole pile of suites now that are better to be measured using drones with the sensors that are sending people out. So I guess the message there is ecologists are like, oh, we're going to be replaced in the field. No, we just need to reskill in this sort of area. This is a comparison of a terrestrial laser scan, which is normally the benchmark for LiDAR, compared with the drone LiDAR stuff. So we're sort of working with CSIRO up here on this. A guy called Sean Levesque, is at CDU as well. And I hope that, so that was the TLS, the terrestrial laser scan, and this is the airborne laser scan. This was the previous sensor, so we get better results now. But what we're after is the stem hits, so we can actually measure the diameter of breast height of the trees. So this is the 3D point clouds of our more recent stuff. So this should drop down. So you can imagine getting this across 1,000 hectares. But once again, then that brings us to data management and analysing that data. It's huge, and they're the things we're sort of working through at the moment. But yeah, incredible amount of information. And so with some of the analysis, we struggled with the LiDAR stuff for a while, but I think we've found some commercial software that we're pretty happy with that comes out of the States. We do things like tree heights. It'll just segment the trees out to individual trees and start pulling out parameters around the crown architecture. So things like crown diameter and crown area and crown volume. So they're typical forestry measures, but they're really useful ecosystem parameters for us to measure. And one of the challenges we do have in the savannah up here with such high resolution data is tying the imagery together. And savannah trees are one of the most difficult trees to work on in the world, I think. So all the sort of algorithms, all the knowledge we have with a lot of the remote sensing stuff is developed in the northern hemisphere where the trees are completely different. We've got easier to work with. We've got sparse canopies here with eucalypt leaves that drip down and you get lots of ground reflectance. It causes a whole array of issues. So it's really good if we focus on some of these common problems we have with the sort of remote sensing and analysis side here. So Hamish and Mariana asked for us to think about some of the key opportunities and challenges in our sectors. So I think some of the opportunities we have is with drones that we can use larger scale assessments of ecosystems. That's really important. It's really cost effective. We've done cost benefit analysis cases that we're happy to share with people on this. The development of technology that is fit for purpose. So as I was saying, our conditions are different. Our applications are often different to other people as well. So we can develop things that are application purpose. The market will take them up. Ecosystem surveys that are more accurate than traditional surveys. I've shown you an example with the height stuff. Calibration of satellite-derived products. So we've got Stefan here. You would know that there's NASA and JAXA and ESA. They often want their satellite stuff calibrated when they first launch a satellite, their Earth observation satellites. And so there's sites that we've previously used around the place here to do that, and drones are also playing a role in that calibration. LiDAR and hyperspectral sensors are a real opportunity. Yes, you need the high-end analytical capacity to use those to their full extent, but definitely for environmental monitoring, they add a whole different dimension there. I think partnering with other organisations in industry to conduct trials in the Northern Territory. So Queensland have got a BVLOS ground set up, I think now, where everyone can go and trial their stuff. There's no reason why we shouldn't have something like that in the Northern Territory, but also like enabling companies to come and test their sensors here in those high environmental extremes. I think this is really critical for this centre. One of the most critical parts is people working on country and delivering environmental programs, particularly for the government. So this is that, pathways to employment for people in communities, those sort of things. And I guess the government does pour, or has in the past put a lot of money into things like, land care and that sort of thing. So it's definitely a way, a department like mine will look at how it evaluates the money that's invested into environmental programs. The challenges, the scale, so BV loss and associated technology and the regulatory requirements around that. So we're doing our foray into that at the moment. We've tried to go get IREX, so I've sat the IREX course, and it was the hardest thing I've ever done. And I would not want to wish that on anyone, so we're sending our 24-year-old recent grad, who knows how to study and stuff, he's going down in 2 weeks to have a go at it, because we're too old to do that sort of studying. Commercialising environmental monitoring, who pays? So unlike, say, a defence sector, some of the construction sectors and stuff like that, environmental monitoring, there's no money in it. It's a public good thing. It's the future of our country, and it kind of sits in the realm of government, but it's not well funded. So we need to think about that sort of thing. But there's other components within that sector, like the mining industry, or people who have a remit that they have to do a certain level of environmental rehabilitation. Operating conditions, as I said, impact on the technology, but they also impact on the pilots. So if you've got pilots out in the middle of nowhere for 3 or 4 days at a time, and it's November, build up, you've got to really manage how your pilots are going, coping in those conditions. So far, so good. We've not had any real issues there, but we do manage that really closely and tightly. So they're all important things to think about in training people as well. Data analysis, so Hamish has alluded to that. It's one of the key capabilities required. It's no good just flying drones for whatever application unless you can do the analysis of it. And it's not that easy. There's people in this room that are trained remote sensing people, and we agree that it's still a challenge. On that side of things, we're currently working with Microsoft in the AI for Earth program, and we're fortunate enough there's a software engineer who's part of that in Darwin, so looking at how we can make this data analysis not so specialised as well. As I said, the Savannah structure are challenges for photogrammetry. One of the other things for environmental monitoring in particular is we don't have a handle on what the species detection rates are. And this doesn't just apply for the plants, the flora, it's also for fauna too. How can we use some of this stuff for detecting fauna? And this is one where it's the potential reliance on technology from the dominant market suppliers. And most people will know what I'm talking about. They work with drones. And it really concerns me because at any time, Defence may turn the tap off, particularly the government, and say, can't use DJI anymore because of a security risk or something like that. And when they first started forcing firmware upgrades down onto the drones, that's when it really highlighted to me the risks there. So you'd be out in the middle of nowhere and all of a sudden you can't take a drone up past 30 metres or, it's... Anyway, just because we came from the open source sector in the beginning, we really noticed the difference. Going with someone who owns 80% of the marketplace. Also, you're also dictated by their development. So, for instance, they're definitely not going into the VTOL market because if they want to go into a market, they need global dominance, basically. So, there's applications that they will not service. So, what do we do there? Nice and easy stuff to operate, but you've got to think about these things. The potential role of, I'm going to call it the drone training centre. And I think you can use drones. I used to be this, don't use drones, don't use unmanned. That's not cool at all. I think the US guys use uninhabited, but that's... I think people now know drones can be used for good. So, there's a hashtag drones for good. That's what I always tag all my stuff with. So, I don't know, that's another discussion. So the potential role, I think, of the centre is facilitating partnerships between industry and researchers to develop technology and conduct trials of platforms and sensors. And that's just not for the environmental monitoring sector, that's for all of them. I think partner with industry in providing research capability and also highly trained talent. That's what we really need, particularly with in government, with the environmental monitoring perspective. And that's not only from the data acquisition, that's the analysis side. Be a hub maybe to coordinate the calibration of satellite-derived products. I think there's a little niche there for that. Investigate developing a commercial capability and providing support for environmental monitoring applications. There's a gap out there in the marketplace. Nobody wants to pay for this at the moment, but I think as the business cases develop more for environmental monitoring, there'll be a push there. BVLOS test ground, and I think that's really important for the training of people to do those types of operations. And training of people on country to support and assess environmental programs. So how do I see us fitting in, or the department as a whole? We, as Hamish said, we're in a very privileged position where we have a forward planned research program that relies on using drones for environmental assessment and monitoring. And we do rely on collaboration. So we collaborate with universities and people where we can. We would love to have research students, masters and PhD students, but many PhD students are with us at the moment working on plant functional trades, which is really exciting. Professional practice placements, we've had them in the past. All of a sudden that well dried up, I think, because somebody left and maybe didn't know we were there, but we had a stream of third-year students coming in and they were great. So happy to keep continuing on with those. We're really happy to partner with Australian companies to produce the affordable fit-for-purpose technologies like we have with the Next Core Lidar, like we will with our Foxtech Baby Shark. So I think also providing cost-benefit analyses of operations and the link to the use of drones by government as well would probably provide a lot of insight and benefit there. And that's it from me, I think.
Any quick questions? Can we move on? Just have one shoot. No? Go.
What was good about how we started is because our chief pilot is a pilot, and also Trevor is a pilot. So when we started, we had that CASA understanding of how to operate in this space. The next thing that we did was we actually have ABCRM, which is a RPAS management program, and what that does, it was good for us because it's available software that we can just link into. So for me as a basic pilot operator, it tracks my certification, how my training's going, but I can also log a job, and in a remote area, I can get my approval process signed off, and then I can log the job so I actually do my risk assessments on the ground, and then once I come back, it's actually looking after the drones as well. So it's our battery management plan, and then also it manages all the background stuff, so our library and our manuals. So it manages to make sure that I've noticed the changes that have occurred. So for us, that's been a really good system, and it's really working well for us. Also too, I did my training with Aaron. So we're using outside experts to do the training that's required. And that being said, you'll see that there's some specialist areas that we need training in. So we're doing our own internal training. So one of the important things about Trevor, as well as being a pilot within the police force, he's also one of our trainers to make sure we're in line with what CASA requires. So that's been very good for us. So that's basically who I am and where we've come from. So now, if we look at what our sector is using drones for. So during the week, we were out at Mount Bundy and we were doing training using their mount facility, so their buildings. So we're practicing flying around buildings. That means for us, we need to work in with what's happening out there. So we need to work with the Marines and work safely under our CASA regulations in the airspace. Right, so that's something that's important for us. Me as a team leader for the Arafura Games, I had to provide my management with a plan for a drone response, as a planned response and an emergency response, And then a drone, anti-drone plan. What does that look like? So that's another area that we are working in as well. Now, as a search and rescue coordinator, I've used drones to put them up in the air to actually try and find somebody. Find where they've been. If it's a car, find where that car is and then where the person may be. And that, the technology that we have now, we're using the sensors that you've spoken about. We're little infants in using those sensors, whether that's heat, and we'll use those in search and rescue to try and find a car or hopefully find a person. So that's how we're using it in that area. And when it comes to high risk incidents, anything you can see on a movie, we are sitting within our CASA regulations attempting to fill that space. Right, so anything you can think of, we are integrating and learning how to do that a lot better. Right, so that is quite a big area for us. So our fire, they're also using drones as well, and that's for all the things you can think of. So they're monitoring how a fire is progressing, their safety, how their teams are going, right? And that's something that they're moving into that space as well. Our major crash, they're actually quite good. They'll do surveys of crash sites, right? So it's quite different to a high risk environment that we're working in. So our major crash members are actually very good at doing site surveys for something like an accident, right? So a little bit different to what we concentrate on. I also want to emphasise too that RFU Games is a good example because our plan response falls under different legislation and regulations than what an emergency response does. So they're two different fields that we need to learn to work in better, being compliant. So what I wanted to emphasise too, I guess which is important, I've found I haven't been a policeman for that long, but people seem to think that police, it's an emergency, we can do whatever we want, right? Where in actual fact, it's the flip side of that. We actually do everything that's required. So for example, and it's a poor example, I have, when it comes to a firearm, I have legislative powers to be able to operate, use, pick up, possess that firearm, but the police actually we go out and get corporate licenses. So we are compliant just as much as everybody else in that space, even though we have legislative powers that give us authority to do that. And that's the same with our interaction with drones with CASA. So I just wanted to highlight some of the things that we do have. I'm just going to go through our manual to do that. So we've got our operator certificate. But hand in hand with that goes our exemption. So we've got flights at night time, flight exemption. We've got flights within 3 nautical miles of an aerodrome. We've got flights outside visual line of sight. Flights near building or people in a populous area. We've also got, in order to do things that in emergency circumstances or plan, we've got memorandums of understanding with the RAF-based Darwin, RAF-based Tyndall. So anywhere we can identify the airspace that would require us to interact a lot quicker and more efficiently, we've gone forward and got the memorandum of understanding with those agencies. So that is a simple for us. So if we need to do an emergency job, we've got our ducks in a row, I guess. We ring ATC Darwin and we tell them what we're doing as in line with our CASA regulations, and they say, yes, we have spoken to you before, we know what you do, and you're right to fly. Alright, so the next thing I wanted to go on with is the challenges that we're facing. So the challenges for us are simply legislation is one of our biggest challenges, because when we operate in that space, we need to do things lawfully, right? So we can't just do what we want, right? So we need to, for example, even though we can fly around buildings and we can fly around populous areas, there is obviously, are we infringing on people's rights? So we need to make sure that we are legislatively compliant. And from jurisdiction to jurisdiction, they're not simple answers. They are not the same answers as the answers that we need here. something that's been interesting for us is we have managers that hear about something somewhere else and they think that it's easy to overlay that here. And I'm sure we're all having that sort of problem at times. So if they hear that a drone can do something, then they expect 24/7 up in the air abilities for a drone that I can see everything. Right? So that's one of our major challenges. It's actually having the information that we need to provide to our managers to tell them what we can actually do. And that's something that we will be looking for in the research centre to help us with those sort of answers. So you can see that we've got our ability to fly around buildings under emergency circumstances, flying around populous areas. Those people that work in this industry are aware of what CAS's regulations are, but what is a real qualification that qualifies someone to do that? What do we actually really need to do? So what we are doing is one of our challenges is to say what makes a pilot certified to be able to fly around buildings under these circumstances. And that's definitely a challenge for us. And the answers are coming from the pilots that have to do that and coming up with reasonable training objectives, and then working with our pilots and our chief pilot to come up with an assessment to say that we are silent. So I think what we can do and how we want to help and get help from this sort of organisation is that the Territory is a great place of how we sit down and have these conversations, yes? And that's why it's important for police to be here. As a search and rescue coordinator, I was one of the first people that flew into Borroloola after the cyclone had passed. And I can only do a good effective job by knowing the people that are there, what their assets are and what they can do for me, and that they will help me. So we use the mining industry, we use local farmers, we use companies out there to assist us in emergency circumstances, and it's these conversations, sitting down doing these, that are important for us. That's why we are here, that's why we're thankful that we're here. So they're the sort of things that are going to help us with this sort of organisation. I think too that maybe if there is a space that in our area that we can help, so if it is a qualification you're looking for flying around buildings, flying in emergency circumstances, flying at night using NVGs, then we may be an area to help you find what those requirements are to certify something. That's how we may be able to give back. What I want to do is just hand over to Trevor. And you wanted to talk about the training that we do, or
We will cover that side of it. So.
And what I really wanted to do was actually see if there was any questions, if there's anything that you wanted to know, anything I can help with. We are a little...
I really wanted to come because he works and he's part of Sky Volunteer. They're doing stuff in Indonesia that we're just not doing in Australia. We're doing some really fantastic stuff. We're line of sight to do rescues. We're not doing Australia because of the regulation. These guys are doing all in Indonesia. So anyway, Cynthia, take it away.
Okay, good afternoon. Hello, my name is Septian Firmansyah. Some of you maybe pronounce it Septian, just like but it's pronounced Septian. I will present the RPAS in Emergency and Disaster Management. And I am from Sky Volunteer. Sky Volunteer is a cool collaboration between volunteerism, business, and innovation. It's managed by Synersia Foundation that I and my friend founded, and tech supported by Payload Indonesia. This is the company in Indonesia that's focusing in manufacturing drones and also the service. We are ready to accelerate this movement and level up the impact for humanity. So what we do, this is what we do in disaster management. The first one is aerial risk assessment in disaster risk reduction, aerial damage assessment in emergency response, and aerial mapping training in disaster risk reduction. I will present you two study cases in Indonesia. The first one is in disaster risk reduction. It happened in 2013 at the case is Negeri Lima flash flood. Negeri Lima is in Ambon Island, the east part of Indonesia. This is the village in Maluku, and at 2013, a river across that village drained even in rainy season. The local government thought that must be a problem at the upstream, but it was impossible to go there by foot, so the fixed-wing UAV chosen for risk assessment at the upstream. We fly the UAV and make the 3D model of the upstream. And this is the upstream. There is a trap water over here. Because of the landslide here. So the water cannot go to the downstream. This is the riverway, and this is the Negeri Lima village. Then we make the station map and identification. This is the landslide, trap water, this is the riverway, and that's the populated area at Negeri Lima village. We also make the topographic modeling and analysis. From this analysis, we understand that in the next 6 months, there will be a flash flood because the trap water at the upstream will be push the landslide to the downstream. Yeah. From the result of this aerial risk assessment done with the BNTB, we understand that there will be a flash flood in 6 months later, and before the flash flood happen, the local government and also the disaster management center in Indonesia, also in the local level, evacuate the people of Negeri Lima. Even there are people that refuse to evacuate and become victims, we can prevent a bigger disaster by appropriate risk assessment. Drone really can save life here. If we didn't done the analysis, didn't make the proper risk assessment, there will be many victims, more than what happened. This is the first case study. The second case study is the Garut flash flood, also the flash flood in 2016. Here in Indonesia there are so many disasters happen all over the years, and this is a very important case in Indonesia. This is in disaster emergency response. Garut is in West Java, in Java Island, near Jakarta. In 2016, a flash flood happened at Garut, West Java. 34 lives and around $20 million losses. The affected area mapped from upstream to downstream using fixed-wing UAV at emergency response. This is the satellite imagery before the flash flood. It's not so good image, but then we make the after. We see it's the flash flood over here and over here. Let's see the before. This data, this spatial data we use to help the search and rescue team, so we can provide the effective way how to evacuate the victim and also the survivor. End of story. Beside as a tool in search and rescue, the result can be used to assess the damage. Also, we can understand that the main cause of the flash flood is at the upstream. There are so many tree losses in the upstream that this is the main problem, and it's not the problem in Garut, but also many places in Indonesia. The main thing we have to understand is the risk. This is the problem we have to understand more. We have to understand the risk more in our area. And by providing the spatial data by UAV, we can choose the optimal way to understand the problem. In this case, disaster risk at an area. By better understanding, better planning, we can save life. Seems like a good story, right? By the case, yes, it's a good story. But we have still many problems. There is many homework in Indonesia. Policy, regulation, managing technology, system operation procedure, human resources, data security, etc. For the cases, this is a good story. But for the whole system, for the integrated system in emergency response, in disaster risk reduction, it's still a problem. Why? Because this good story didn't used by the government, didn't used by the authorities to create the standard operating procedure to optimizing the UAV, the drones, to save lives. It's only by cases. In emergency response, there are many people, there are many organizations use the drones, go to the emergency sites, bring the drone, etc. But it's only a gimmick. They only fly the drone, and that's it. It's nothing. It's useless. This is the problem. Because there is no good regulation, there is no good policy, and there is no the system operation procedure how to use the drone and go beyond it. How to analyze the data, how to save, how to optimizing the drone. That is the problem. And also human resources. In Indonesia, right now there are many pilots, there are many GIS engineers. But to ask them use their skills in disaster emergency response or in disaster risk reduction by doing it voluntarily, it's another story. In Sky Frontier, there is only maybe no more than 10 people they want to join. Actually, the government also have the power to do this. There is the technology agency in Indonesia that has more powerful drones, more that can fly and take the data more than us. But they only collect the data. They didn't use it to analyze the problem or the risk. That is the problem. That's why in this session, Professor Hamis asked me to what is the next collaboration with the RPAS artists? Oh, so many. It's so long. The first one is joint research. We can make a research in Indonesia. We can do many research in disaster risk reduction, in disaster emergency response. Many things we can do. Right until now, Sky Frontier only use the drones for data collecting, data mapping, etc. But we can, by the research we can do much more. We can deliver the aid to the victims, to the survivor. We can make the drones how to prevent the fire at the forest. Yes, sir. Many things we can do. Supervisor networking, training and license, commercial study, data and standard. In Indonesia, there is a regulation. There is a regulation how to use the drones, but not as strict as in Australia. Just like in Lombok, in the 2018, last year, we fly the drones, the fixed wing UAV in Lombok, beyond line of sight. And it's not only us, not only Sky Frontier do that. There is, beside the government, there is two more teams from, actually, they are my senior in campus in ITB. They only fly the drone without permit from the authority. In Indonesia, it can happen, but it's the problem. In Sky Frontier, we try to stick to the regulation. How to fly the drones with permit. Yeah, there's many things we can do. How to save lives in emergency response, and also to analyze the risk at disaster risk reduction. And this is we are looking for in collaboration with this center. Thank you. Hatur nuhun, and thank you.
Thanks. Yeah. Right, thanks very much. Yeah, interesting to see that some of the same, what commonality there in some of the issues. Someone told me once that we're talking about how the centers in Darwin. Someone told me once that there's 4 hours south of Darwin, there's 20 million people, but 4 hours north of Darwin, there's 400 million people. So it's a really good analogy there. And we really definitely, the centre definitely wants to be collaborating with our Indonesian colleagues. Are you still getting here? It's the vote.
Thanks, Hamish, and while we're getting it up, we did it this morning. Thank you, Hamish and Mariana, for inviting me here. Our company's based in Sydney. We're a SME that's actually working at the University of New South Wales, so we've actually forged a relationship between a company and the university, and we're actually working on site with their computer science people, and they have teams of robots that play soccer. And as soon as I thought that, I thought we've got a commercial application for that, and that's teams of unmanned surface vessels. So Ocius is a 20-year company. I hope we can actually get to talk to you about it. When I saw the title of the thing being pilots, in the marine world, of course, a pilot is someone who brings a ship in. So goodness, all right. So that's the wrong one. I think that's there's one there marked Darwin.
Right, sorry.
And so we're really excited to be part of this initiative. There's no need to change the name of the CRC because it does also include marine technology. Our background is that we came from 20 years ago. We formed a company. We won a solar boat race in Canberra, and we started for 12 years building hybrid electric ferries. And when inconvenient truth was a thing, and when oil was $120 or $150 a barrel, we got orders for building 6 ferries around the world. And that was a really interesting time for us in the sense that we developed technology, we developed contractors and supply chain. And then when the GFC hit, the business went bad because no one's really, it's a nice to have thing to be green. And it doesn't, if you're not saving money, then it makes no sense. So at that point, we got an inquiry of how would we use our technology to build a platform that can go to sea forever. And we said, this is what we do. So thank you, Mariana. This is my entire talk. When I was presenting this, building this morning, I thought this is my entire talk. What we're talking about is right now we can do persistent marine surveillance using the energy of the ocean. And if you look at that slide, you can see that we've got solar panels, and you can see the shadow here. So we have solar panels on both sides of the sail. So right now we're getting solar from here and from the sail. So at 9 o'clock in the morning, if the sail's down, we get about 30 watts in. Put the sail up, we get 300 watts in. You can see it is a sail. So we use wind power, and the vessel's hull is designed by the architects of Wild Oats, the people who Sydney to Hobart. So it's got a great marine heritage. And this highlighted thing underneath here is a rudder flipper. So at the front of our vessel, and I'll show you a video later, as the vessel pitches, it drives itself along. So in sort of the sea states, next slide please. So this is the background of our company. This is me on a boat back in 1997, winning a solar boat race. We then got contracts to build various ferries around the world. There's 4 of these ferries still running in Hong Kong. If you play golf in Hong Kong and you go to Sai Kung and get the ferry to Sai Chau, you'll get on one of an Australian-built hydroelectric ferry that's using half the fuel of a conventional ferry. We then got this question, could we build a drone that could go to sea forever? On our own nickel, we built this thing called Nemo, which in Latin means no one. And we teamed up with the University of New South Wales and Steva International. In 2015, we got a contract under the Defence Innovation Hub to build a drone that could take a Thales array, a underwater sonar array. And we signed the contract, and we built this thing we call Bruce, because if you're a fan of Finding Nemo, then Nemo, the bigger, badder version of Nemo, is Bruce. And also the founder of Steva International is Bruce Steva. And we're also working with a guy who was our flipper guy who we'd worked with for 20 years, and his name is Bruce. So we're surrounded by Bruces. And then last year we got another contract, and I'll just talk about that contract in a minute. Next slide. So when we got this question, can we build a platform that can go to sea forever, we bought a little 18-foot boat and said, yeah, we can. Obviously we've got the power and the payload and the performance, we can do that. We built a whole lot of models. We did a lot of wave tank testing. So this is testing for, just turn the sound off, thanks Marion. We built a whole lot of these prototypes and tested them in a wave tank, and we worked out the pitching of the vessel. The flipper at the back doesn't make any difference, the flipper on the keel doesn't make, but the flipper at the front gets all your power. And we tried a whole bunch of different hull shapes, and then next one, Marion. And then we tested the sailing, because we wanted them to be able to sail. And then finally we built this thing called Nemo. So out of that came, we already had the solar sail technology, so you can see that it is a sail, and it's also a solar collector, and it's on a actuator, which is just a tilt and trim Mercury outboard that raises and lowers it, and when we can slew it. When we got the contract with Thales, we said we'd already signed it, and they said, oh, we want to put this 25-metre garden hose on the back of your boat. And I said, we can do that. And they said, oh, it's on 100 metres of 10mm cable. And we said, oh, okay, so where do you put that normally? Oh, we put that on the back of the boat. And I said, well, you can't, and how much does that weigh? 110 kilos. So we're not going to put that on the back of an 18-foot boat. We can't do that. So we developed this winch that goes, it's a cassette, which we can give to Thales. They can put their array on it, and we can put it into the boat. And we can put any sensor and lower that sensor to 100 metres with a 10mm cable. And if you've got a 5mm cable, we can lower it a lot more. And then the other thing we came up with is this rudder flipper thing, which at night time on a still no wind in a 2-knot current, it's saved our butts in the last week. Next slide. So press the button, thanks. So this is Bruce, early sea trials. There's a number of things, obviously. This is 6 knots. We can do that for a couple of hours. We can do 5 knots for 8 hours. We can do 4 knots for 24 hours. Mainly used for getting out of currents and avoiding other ships. We can raise the sail. Here is Bruce arriving at a waypoint and just doing figure of 8s. A whole bunch of different ways we can stay on station. Just sailing. So we're really sailing in different conditions, and in these sort of situations we're just getting the incidental sunlight, but it's still we're getting between 200 and 300 watts coming in on a sunny day. So this is in Botany Bay, getting stronger winds, and in the last week we've been testing off the New South Wales coast, and we've been developing the different algorithms to improve the sailing, and we've improved the sailing considerably. Putting the sail away, and then importantly for Darwin, and I was saying to somebody earlier, you might think Darwin is a remote area, but for defence, Darwin is the centre of the universe. We've presented a number of times to defence, and 2 things they ask about is cyber security and surveying the area between us and the north. So one of the things that's important for this technology is that we've got a platform right now that you can launch from the boat ramp. So all the infrastructure we need up here is a shed and a boat ramp. And some people. Next slide. So we participated in some war games recently. Just click, thanks. And one of the things, this is the last day of the war games, and we're towing the Thales array, and we're out listening for something, and we're about 5 miles out of sea, and this 40-knot westerly came in, and so we had to make our way home. And again, we can do this for a few hours, that sort of speed and that sort of thing to get home. And it was much worse further out, but the guy driving the speedboat couldn't hold the camera out. So that's when we're actually inside the bay. Back to that. The other thing, so the weather at these war games was so bad that most of the time we were the only robot out there because the unmanned aerial vehicles couldn't fly and the other unmanned surface vessels and the support vessels couldn't operate. But one of the things we did do was our command and control system was able to control 4 vessels at the same time. This Navy vessel here, 2 of these underwater UUVs, and what we were doing was the mothership was sitting there, the potential minefield was here, and the USVs, the Blue Bottle and the WAM-V were over the area and guiding the UUVs to mow the lawn. And instead of them finding something and then going back to the mothership and being recovered and downloaded and then saying, well, now we can send something to that coordinate to investigate a mine-like object, where they were popping up, Wi-Fiing it to the Blue Bottle, and then we were Wi-Fiing it back, or radioing it back to this UK command and control system. And during the games, we were controlling 4 vehicles, and one man up in this control centre was controlling 9 robots, which was a nerd world record for the control of one man. Because mostly when you see people operating unmanned stuff, you've got 5 guys around a computer operating one vehicle. In this case, it was one guy controlling 9 vehicles. And the other amazing thing was he said, okay, I want you to go and investigate this part of Jarvis Bay and all send out the message to the unmanned aerial vehicles and the unmanned surface vessels and the UUVs, and they would all come back and they would give him a list of things like, I can be here in 10 minutes as an unmanned aerial vehicle, but I can only stay for 30 minutes. And we could say, we'll be there in 30 minutes and we can stay forever. And it would give him a scenario and he would go, okay, we'll do that one, and press a button. And that would have, in the past, taken hours of people with charts and little models and pushing them around. This took less than a second for this computer system to say, okay, this is how we would investigate this area. So Unmanned Autonomous Warrior was a fantastic in November of last year and involved the Five Eyes countries, so all the English-speaking allies. Excellent. This is our winch, next one. So this is a rope obviously, but we can put any sensor on a cable and lower it to variable depths. And we can pull it up on the back of the keel and transport it somewhere and then lower it. Yes.
So I got one question. So you mentioned there that you do have a blanket approval for flying within the 3 nautical miles of Darwin Airport? No?
No, we've just got lines of communication, a memorandum of understanding.
Okay.
Yeah, and I can give that to you so you can have a look at it.
Sorry.
So we've looked at our stakeholders and where we could see problem areas, and we've been on the forefront to step in and make sure that we've got those lines of communication. They're really quite specific and laid down. So for me, if I wanted to do training out at Peter Macaulay Centre at Berrima, I'm within that 3 nautical miles. So I simply know